Alright guys, today we are going to be talking about the line of best fit. So the line of best fit is basically a line that kind of cuts our data in half. Now this line isn't perfect, as you can see on number 2. It gets as close to as many dots as possible, with still trying to cut the data in half. And I drew these on, and they're so lovely. Okay, so this is a decreasing slope and an increasing slope. So I've already done the line of best fit part for you. And now we need to estimate our slope and our y-intercept. So yesterday we talked about the slope and the y-intercept and we reviewed that. Remember, the slope is your rise over your run. That's what M or slope is. And your B is your y-intercept. So it's where your line crosses the y-axis. Okay, so on these lines, since not every dot is on the corner of a box, we're going to find 2 dots that are kind of on the corner of a box, and we're going to figure out the slope of those 2 dots. So I'm going to start on the left-hand side. So this dot looks like it's on the corner of the box and on the line. So that's, actually this dot is better. So we're going to pick this dot. And it looks like this dot is also on the corner of a box and the line. Okay? So we're going to figure out the slope between this dot and this dot. Now we have to be really careful on our scales and make sure that we count correctly. When we figure out the slope, we always count the rise and the run. So we have a rise of 1, 2, and we have a run of 1, 2. And that's because each box is worth 2. Although every other box is numbered, if I were to number the boxes in between, it would go 1, 2, 3, 4, 5, and the same going up. 1, 2, 3, 4, 5. So you have to be really careful on your scales. So each box going up is worth 1, and each box going left and right is worth 1. So my slope is 2 over 2. Now remember, we want to reduce, so that would be 1 over 1, or just 1. Now, this slope is decreasing, so if I stand over here on the left-hand side and I move from left to right, I'm going downhill. So downhill means decreasing slope. So when I have a decreasing slope, I need that cute little negative to follow through. So my slope is really -1 for this line of best fit. Now the next thing we need to do is figure out our y-intercept. So it's where our line crosses the y-axis. Our line crosses the y-axis up here at 12. So 12 is going to be my B value. Okay, so now we need to put together our prediction function. So our prediction function is the same thing as our line of best fit, and we talked about the line of best fit yesterday as our slope-intercept equation. So our prediction function, or the slope-intercept equation, is y equals mx plus b. So we're replacing our m and our b with the values that we just got from looking at our table up in the top. Okay, so our prediction function, again, is our slope, and our slope-intercept formula in our equation. So y equals, the slope that we got was -1. We always put an x next to our slope, and then we add our y-intercept, which is 12. Now we don't need to have this -1 there. Well, the 1 doesn't have to be there, so we could rewrite this slope prediction formula as y equals -x plus 12. So this is the prediction function for this line of best fit for the graph. And that basically means that if we were to look beyond this data and we asked you questions about these numbers or these numbers over here on the x-axis, that we could predict what would have happened using this formula. And that's what we're going to do today as well. Now, the last question says, what does the slope represent in this context? So remember, the slope is your rise and your run. So sometimes there is some information on your rise and run. So maybe this is days and then money you spent. Since we're decreasing, so we'd be losing money. So our rise goes with our y-axis. So our rise is our money that we spent. So that would be money spent. And our x-axis is our days, our run. So days passed. Okay, so that's what you would write for what does the slope represent in the context. You're just putting your y information first and then your x information second, because rise is y over x, or rise over run for your slope. Anyways, so that's how you do that. So let's look at one that's increasing. Okay, so again, I'm looking on the line. I'm trying to get my dot on the corner of a box on the line, which is kind of tricky to find, but I see one here. It's on the corner of a box, and then I'm kind of looking, and if it gets pretty close, we're just going to take that value. This one's kind of tricky. We'll just take the 0. So we'll go this to here. So that'll be my slope that we'll be calculating. Now each box going up is worth 1 because it goes 1, 2, 3, 4, 5, 6, even though they're not all numbered. So this is a rise of 1. Now going across, however, each box is worth 3. So you have to really pay attention to your scale. So over from here to here is 3. So my slope is increasing, so it's going to be positive, and it's rise of 1 and a run of 3. My B value, or my y-intercept, is where my line crosses the y-axis. So it crosses down here at 0, so we are going to put a 0 here. When we write our prediction function, we're writing our slope-intercept formula, so y equals mx plus b. We're replacing our m and our b with the values that we got from our line of best fit on our picture. Okay, so y equals 1/3 x, so that's our m, goes there, and then plus our b value, which is 0. Well, we don't really need that, so y equals 1/3 x. So that is our prediction function for this data. Okay, so then what does the slope represent in this context? Well, let's just say this was time, how about this? Let's go with money spent and then rides. Maybe you're at like Lagoon or something. So your money is increasing as you go on more rides. Oh no, I'm so sorry. Cat. Okay. So money spent and rides. So our y-axis is our rides. So we always say the y first. So this would be rides per money spent. Okay, and you can use per means a fraction, and remember your slope is rise over your run. So this would be your y value over your x value, or whatever your y-axis says versus your x-axis. You can say per, you can say versus, you can say and. So there's a bunch of different keywords you can put in this spot to separate your y value and your x value words. Okay, now let's look at E. So E is a little bit tricky. This is the hardest part, is to predict what will happen. So when the x value is 12, okay, so that means that I will take this x and replace it with 12. So what we do here is we would say y equals 1/3, and then instead of x, we put the 12 there. So 1/3 of 12 would be 4. So when x is 12, then y is going to be 4. And you can do the same thing when x is 100, and you can even use your calculator to figure this out as well. So on your calculator, I'm going to use my phone calculator. Okay, so on your calculator, you are trying to figure out, oops, this way. So parentheses, 1 divided by 3 parentheses times 12, so that is 4. And then you can do the same thing for 100. So parentheses 1 divided by 3 parentheses times 100, which would be 33%, or not percent, sorry. So y equals 33.3. And then the same thing over here. So we use our prediction function to predict what will happen in the future or what happened in the past, because sometimes we just have a brief piece of information. So we are plugging in 12 and 100 into our x value. So y equals negative, take out the x and replace it with a 12, and then plus 12. Well, negative 12 plus 12 is 0. And then the same thing with 100. Y equals negative 100, because that's where our x is here, plus 12. So we can do that in our calculator if you want to. 100 negative plus 12 is equal to negative 88. So y equals negative 88. So you have the same thing on your worksheets for today. You have a scatter plot that was been drawn, and then we drew in the line of best fit for you so we could ask similar questions. So on number 5, company XYZ makes and sells widgets. So we are trying to figure out the weight of the widget and the number of widgets. So it says on the scale where the number of widgets is, which is on the bottom. Notice each box is worth 2, and then the weight of the widgets is going up. So again, each box is worth 4. So you have to really pay attention to your scales. So we've already done this first part for you. We drew a line of best fit, so you have to estimate your slope and your y-intercept. Okay, so you're looking where your line touches the corner of a box and there's a dot there. So all of the pieces all together. So there's a dot here and there's a dot here. We can use this one. So we have a rise and a run. So we count our rise, so 16. Over our run, which is 4. And you have to reduce if you can reduce. So 16 divided by 4 is 4 over 1, or you can write 4 for your slope. And your y-intercept is where your line crosses the y-axis, and at this time it's at 0. We write a prediction function, so that's using the y equals mx plus b. Given your m and your b came up here. So y equals 4x plus 0, but you don't need that for 0 right there. So y equals 4x. What does the slope represent in this context? So the slope is your y over your x. So your y data is your weight, and it's per widget. Oh, number. So you just write whatever you see on your x-axis, number of widgets. Okay, so this is your x or your y-axis and your x-axis and what they mean. What does the y-intercept represent in the context? So the y-intercept is where your line crosses the y-axis, so it's crossing at 0. So that means that we have 0 widgets and 0 weight. Okay, and then predict the weight of 50 widgets. So our graph doesn't go to 50, or else you could kind of use our graph to figure out what the weight of the widgets is. So the widgets is your x, okay, because it's on your x-axis, right? So you are going to replace your x in your linear equation. So y equals 4. You're going to take out the x and replace it with how many widgets we have, which is 50. And then you're going to do this in your calculator. So you have 4 times 50, and that is 200. So the weight of 50 widgets we're predicting to be 200. It could be a little bit less or a little bit more, and it's 200 pounds, but that's about right. Okay, if you have questions, please let your teacher know. This is an example for you. You have 2 more to complete on your own. Have a great day. Bye.